Bismillahirrahmanirrahim. Assalamu Alaikum. Welcome to my YouTube channel. Today we will discuss about new syllabus physics SSC to unit number 10. Simple harmonic motions and waves. Today we will discuss SLO based question according to FBISE requirement. Today we will solve the numerical problem of unit number 10 according to SLO base. Now today we will solve the question number 1 to 6 first part and remaining in next parts. Inshallah. Today, first of all, solve the question number 1. When an object is oscillate with a frequency of 0.5 Hz, what is its time period? In first question, given that when an object oscillates with the frequency is 0.5 Hz, what will be the time period? So, first of all, write the given data. Given data, frequency f is equal to 0.5 Hz. Now, required the time period t is equal to question mark. We use the formula y t is equal to 1 upon f because time period is the reciprocal of frequency. So we use the formula t is equal to 1 upon f. So solution, putting the values t is equal to 1 upon f is equal to 1 upon 0.5. So 1 divided by 0.5, then time period t is equal to 2 seconds. Now in question number 2, determine the restoring force of a spring displaced at 1.5 meter with the spring constant of 30 Newton per meter. Here, first of all, write the given data. Displacement is equal to x and x is equal to 1.5 meter. And value of spring constant is equal to k and k is equal to 30 Newton per meter. Now, required that restoring force. Restoring force is equal to question mark. Formula that we use in simple harmonic motion, restoring force F is equal to minus kx. In solution, putting the values, restoring force is equal to minus kx, putting the values minus into 30 multiplied by 1.5. Now, 30 multiplied by 1.5 is equal to 45. So, the answer of restoring force is minus 45 Newton because negative sign shows a restoring force. Now, in question number 3, given data and according to the statement, a body of mass 0.2 kg is attached to a spring placed on a frictionless horizontal surface. The spring constant of the spring is 4 Newton per meter. Find the time period of oscillation mass spring system. Here, mass spring system, we can find the time period. So, first of all, write the given data. According to statement, mass m is equal to 0.2 kg and value of spring constant k is equal to 4 Newton per meter. Now required that the time period t is equal to question mark. We have using the formula, we know that in spring constant time period is equal to 2 pi m over k. Then we use the formula t is equal to 2 pi m over k whole square. So putting the values, then We have find the solution. T is equal to 2 pi value 3.14, value of mass 0.2 divided by the value of spring constant 4. So T is equal to 2 multiplied by 3.14 is equal to 6.28. Multiply by 0.2 divided by 4 is equal to 0.05 whole square. First of all, taking the square root of 0.05, then multiply by 6.28. Then time period T is equal to 1.4 seconds. Now in question number 4, according to the statement, at what angle must be a pendulum be placed to correct a restoring force of 4 Newton on a bob with the mass of 500 grams. First of all, write the given data. In given data, restoring force is equal to 4 Newton and mass M is equal to 500 grams. 500 divided by 1000 is equal to 0.5 kg. Write the required angle is equal to theta, theta is equal to question mark. Then we using the formula F is equal to mg sin theta, because due to this force body is moved in a mean position, so F is equal to mg sin theta. Now for solution, putting the values F is equal to mg sin theta, then theta is equal to sin inverse F over mg, because here mg is multiplied, then other side it will be divided. So sin theta is equal to F upon mg, then theta is equal to sin inverse F over mg. Putting the values, then theta is equal to sin inverse 4 divided by 0.5 multiplied by value of g 9.8. Then first of all 4 divided by 0.5 multiplied by 9.8, then taking the inverse of sine. So theta is equal to 54.6. Then the answer of this question, angle theta is equal to 54.6. Now in question number 5, what is the gravitational field strength at a point of moment at an altitude of 8,954 meters? If pendulum with a length of 1 meter has the period of 2.01 seconds. First of all, write the given data. Length L is equal to 1 meter and time period T is equal to 2.01 seconds. Now required that the gravitational field force strength is equal to G. So we using the formula T is equal to 2 pi L over G from simple pendulum. Now in a simple pendulum, time period T is equal to 2 pi L over G. Now putting the values in formula, T is equal to 2 pi L over G square root, then taking square on both sides. So we have T square is equal to 4 pi square L over G. Here 4 pi square L over G. Then G is multiplied on other side and T is divided here. So G is equal to 4 pi square L over T square. Then putting the values, so G is equal to 39.4384 divided by 4.0401. Then 39.4384 divided by 4.0401, then value of G is equal to 9.761 meter per second square. In question number 6, given statement, a sound wave of a length is 1.7 multiplied by 10 raised to power minus 2 meter. Calculate the frequency of sound if its velocity is 343.4 meter per second. First of all, write the given data. Given data, wavelength lambda is equal to 1.7 multiplied by 10 raised to power minus 2 meter, and speed of sound V is equal to 343.4 meter per second. Now required that frequency f is equal to question mark. Then formula we have used, f is equal to V over lambda. Here we know that V is equal to f lambda. So f is equal to V over lambda. Putting the value in above equation, then we have f is equal to 202 divided by 102. Now the value is 2.2 multiplied by 10 raised to power 4 hertz. In next video with next lesson, best of luck. Allah Hafiz.